Hey, welcome back. So, law of conservation of mass. In previous lessons, we talked about law of conservation of matter, where we were really looking at just atoms. We were just counting atoms on both a reactant and a product side. And there's so much more to it than that. This video is, again, just sort of an intermediate step between the basics of where we were, where we wrote a chemical equation for a reaction, and then we balanced that skeleton equation, skeleton being the unbalanced equation, into a balanced form, counted atoms again on both the reactant and the product side, and remember everything balanced out. So for instance, remember we had chlorine, and remember it's diatomic, that's where we get the subscript of 2, and then we had sodium iodide. And we talked about how this was an anionic single replacement reaction. If you need to watch that video to figure that out, if you've forgotten how to do that, go back, watch that video that I from the playlist on this. Explains in good detail for that. And we saw here that when this reacted, that we got sodium chloride and iodine that formed. And then we remembered that we see that we had 2 iodines here, so we needed 2 on this side, right? So remember the 2 right here, there's 2, so iodine, when it bonds, it's like this, all right? And then, of course, there's valence electrons around it, but it bonds, and this is 2 of those that are bonded together. Remember, that's a covalent bond right there. In this molecule here, we've got sodium and iodine mixed together, right? And so there's an ionic bonding pattern going on there. So remember, go back and watch those videos if any of that is a little unclear. You can add coefficients to change the number of particles. The subscripts tell you how many you need for that molecule or compound to be stable. Okay, when it's bonded. So now on the reactant side, since we have 2 iodines, now we also have 2 sodiums, which works by putting 2 on this side, which gives us 2 sodiums and 2 chlorines, because we got 2 chlorines over there. And remember, everything balanced out well. So now right here, what we have is the law of conservation of matter, really, law of conservation of atoms, if you will, where we just count atoms on both sides and we realize that, hey, everything is balanced. We go a little further with this now, and we realize that in real life, you're not just looking at one molecule or one atom or one compound. You're looking at a huge number of these. Now that's a lesson for another video that you can go watch. Right now, what we're going to do is sort of an intermediate, where we're going to talk about a step between counting atoms and the concept that if atoms are matter and they have mass, then everything in this reaction also has mass. So to do that, we obviously need a periodic table. So let's come over here. Here's a periodic table, and we see chlorine. Well, right there you can see chlorine at 35.453. That's the mass for chlorine. So the question is what do we do with that? Let's go back to this. So just a quick side note, 35.453. So you could use the entire number. However, in my class, typically, because of the instruments that we have, because of the balances, the scales, and everything that we have, the estimated digit for the scales that we have is in the 100th place. So for that reason, what we tend to do in class is we look at the next number and ask ourselves, would it round that up? And we can see here that it obviously wouldn't. So 35.45 would be the value that we're going to use for chlorine. Now the question is what's the unit? Well, we can't say grams. We're just talking about 2 simple little chlorine atoms that are bonded together. So there is a unit called AMU, and it literally means atomic mass unit. Okay, the unit of mass for the atom. All right, so now you erase all this, Let's go back. So let's do some scratch work down here. We've got our chlorine molecule. So chlorine, colon. So we have 2 of those times the 35.45 AMU. All right. So now we go to our calculator. We got 35.45 times 2. That gives us 70.9. All right. 70.9. Now we're going to write 70.90. And again, the reason why? Well, we see here all these significant digits. We want to match that up. So we know that right here, this has a mass of 70.90 AMU. Okay. So now we have our 2 sodium iodide. So we've got sodium and we've got iodine. So obviously we go back to, you guessed it, periodic table. We find sodium. Sodium is a metal. We come over here and there's our sodium, 22.990. We come back and we realize 22.990 would round up to 22.99, right? So remember, 22.990, that 0 would not round that up. Pretty easy math. All right. So we've got 2 sodiums, 2 iodines. This is times 22.99 AMU. Okay. And then iodine. Iodine's a non-metal. We come over here. We see 126.904. Don't worry about all these other numbers and stuff on the screen. Just focus on right there what we need to focus on. Okay? Just focus on right there what we need to focus on. 126.904, which would be 126.90, right? So 126.90 AMU. And of course, that's multiplied it because you got 2 of those. So that's 2 times 22.99. That gives us 45.98 AMU. And then 2 times 126.9 gives us 253.80. Remember, we're looking at those sig figs. So if we add all that together, we get 45 plus 9, and we get 299.78. 299.78 AMU. So all we did was add up the mass of 2 sodium, 2 iodines. So right here, sorry about that. Right here we have 299.78 AMU. All right. Done. So now let's get all this out the way. We just need, this is just scratch work. You can always come back to this part of the video and watch it over again. So now let's go to the other side. We have 2 sodium chlorides. So that's sodium and then the chlorine, right? So we've got 2 of these and 2 of these because that coefficient tells us we have 2 of all of that. Well, sodium, we already know, is the 22.99 AMU, just like it was before. Chlorine was the 35.45 AMU. We just do some math. 22.99 times 2, 45.98. Those numbers should sound familiar. Then we've got 35.45 times 2. There's our 70.90, 70.90, right? And again, those are some more familiar numbers. Add those 2 numbers together. Double check my math for me, but it should be 116.88 AMU. So right here, this is 116.88 AMU. Now we've got our iodine. So there's 2 of these times, and remember that was 126.90 if I remember correctly, right? Yep, 126.90. Okay, 126.90. 126.90 AMU, atomic mass units. So 126.9 times 2. There's 253, right? 0.8. And then, of course, that's going to be 0. Right? And then it'll be AMU. 253.80 AMU. All right, so now let's get all this out the way. All right, I'm just drawing this dotted line so you can kind of see the difference between the reactant side and the product side, okay? So if we were to add these two numbers together, so 70.90 plus 299.78, we get 370.68, and of course that's AMU, because you can add like units, correct? If we add these two together, 116.88 plus 253.8, we get, lo and behold, 370.68 AMU. Law of conservation of mass holds true because the total reactant mass, that's this side, equals the total product mass. It balances out, okay? And it should. If it doesn't balance out, then you just simply back up each step. Either you've punched a number into the calculator incorrectly, or you wrote one or more of the reactants and products incorrectly. So you can see from this that if you don't write the formula correctly, you're not going to have the correct number of atoms, which means you won't have the correct amount of mass, which means it doesn't balance out. So this becomes a simple math problem of just making sure that you literally count all of your parts correctly. I had to get a sip of coffee. All right, now I'm ready for something else. So let's try another example. If I remember correctly, we had calcium oxide and we had water. And we showed its synthesis into calcium hydroxide, right? Again, go back and watch that video. All right, so let's do the same thing here. So let's see what we got. We've got calcium oxide. So that means we've got calcium and oxygen. Let's go to our periodic table. So there's calcium. You can see right here, 40.078. That would be 40.08. Okay. So there's one of each of those, 40.08 AMU. In this reaction, it's already balanced. You don't have to do anything else. The coefficients just stay 1. So this is just one of those times where it stays 1. But don't let it freak you out. If the coefficients, I don't care if the coefficient is 11, you just multiply by 11 by whatever the mass is. So don't let that freak you out. Okay. So obviously this would be 40.08 AMU. Let's go to find oxygen. And after you do enough of these, you'll kind of memorize these. There's certain ones you use often, like oxygen and stuff like that. So 15.999. That last 9 is going to round. This 9 is going to round that 9 up to a 10, 0, which would then round up the one before that. So we're going to get 16.00, right? That kind of makes sense. Let's go back. So we've got, go back to my color here. We've got our 16.00 AMU, 16.00 AMU. If you add all that up together, all right, we get 56.08 AMU. So we know the mass for calcium oxide here is 56.08 AMU. Okay. All right, let's go ahead and clear this space. And we've got water. All right, so hydrogen, oxygen. Well, we can see there's 2 hydrogens and 1 oxygen. Oxygen we just did, so that's fresh in our minds. We know that's 16 AMU. Hydrogen is really easy as well, but if we need to come back and look. 1.008, that's going to be 1.01. So we're going to go times 1.01, and that is still AMU. So that would be what? That would be 2.02 AMU. That would be 16 AMU. And so this number here is one that you will actually use quite a bit. So there's your 18.02 AMU. Okay, pretty straightforward. Let's go ahead and... So now calcium hydroxide. We got calcium hydroxide. So we list out, we've got our calcium, we've got our oxygen, and we've got our hydrogen. So there's one calcium. That 2 right there means, like a distributive property, 2 times everything that's in there, right? So that means we have 2 oxygens and we have 2 hydrogens. Well, we just did this, so we know this is 1.01 AMU. We just did this one right here. We knew that was 16.00 AMU, correct? And calcium, in case we forgot, it should be 40.08 still. If we go down, 40.08. Okay. So 1 times that would be 40.08. You can see this is mostly tedious than anything else. 2 times 16, 32 AMU. 2 times that, that's gonna be 2.02 AMU. So let's see, we've got 40.08 plus 32 plus 2.02 gives us 74.10 AMU. So here we have 74.10 AMU. So now, let's see, let's get this work out of the way. If we were to add these up, 56.08 plus 18.02, we get 74.10 AMU. Balanced reaction. It works. If you use your numbers correctly, it will work. I promise you it will work. If it doesn't work, you've done something wrong. Even one simple thing wrong. Your job is to go back, figure out what I did wrong. And typically, it's always a chemical compound formula is not written correctly, and or you did not balance it correctly, or you just simply everything is just written incorrectly. So it's usually that's the case. Focus one compound at a time. Get that formula correct. Balance it. Once you do that, then the numbers take care of themselves. And then, I tend to often type into the calculator very quickly, and I'll think I hit a button, pressed a button, and I didn't, and I'll get some weird numbers. And when they don't match up, I know I've done something wrong. Just back up and figure out what I did wrong. So I hope this helped. No matter what the reaction is, what type it is, how you classify it, etc., what the coefficients are. Doesn't matter how many subscripts or whatever is there. You just count the parts, multiply it by the mass, and you got your answer. All right. So hope that helped. Stay curious. I will see you in another lesson soon. Good luck. Work on those practice problems, and reach out to me if you need some help. Bye.